All right, class. So this is 6.5, and we're assessing normality, or is a data set normal? Now we've looked at this, and what did we only look at? We looked at the histogram and we looked for the bell shape, right? Well, what if you're not quite sure? Like even on your last project, I will give it to you if you're have good reasoning on why, or that lab on why you picked if it's normal or right skewed. So let's be a little more specific. So what we're going to focus on is right here. So it says we're going to inspect that histogram. We're going to look for it to be a bell shape. We're going to identify outliers because if you have too many outliers, then we just say it's probably not normal. And then we construct that QQ plot or normal quantile plot. So this kind of in your note packet is going through all of those ideas. So we always start with the only thing we've kind of looked up at till now is the histogram. The other thing that is we can look at with the histogram that we have talked about is mean, median, and mode should be about the same, right? Because the middle should all be the averages. But the mode's hard because it sometimes, happens to not be. So mainly median and mode, but or median and mean. So that kind of goes in with the histogram category. This one says this book can be argued a little bit, but we're going to go specifically with this author and this book says, and that one says one outlier is okay. More than one, not okay. So we have to decide if there's an outlier. Remember, the outlier can be found by taking that quartile 3 and adding 1.5 times the IQR, which I will show again today. Or again, that quartile 1, this is looking kind of at that box plot or breaking it into 4 pieces. So that quarters, let me just draw this. If I take my data, right, and we have this box plot looks like this and like this, we have broke this data into 1/4, 1/4, 1/4, 1/4. Remember this right here, which is the median of the lower half, is quartile 1, and this is our median. Ooh, I don't give myself very much room. And this is quartile 3. So when I break it up, basically it's like, okay, so we're at the top of that quartile 1 or that quartile 3, but if we times by 1.5 times the IQR, then we can see if it's above or below. So easier way, box plot on StatCrunch automatically gives you your outliers. It does the formula for you. So that's kind of cool. It literally takes the IQR and times it by 1 and adds it and subtracts it to those numbers. So we'll look at that. Normal quantile plot is called the QQ plot in StatCrunch. And basically, we already looked at the histogram. We're like, dude, that looks bell shaped. And then I can't believe we just said dude, but whatever. The next thing we'll say is there's only one or less outliers. Great. Now we can do our quartile plot, right? And it should form a line, straight line. I have it highlighted right there. So you don't even do the QQ plot if your histogram's crappy and not forming, it's skewed to the left, skewed to the right, not forming a bell. If you're not sure, you should keep going, look for outliers, look for normal. So that's all we're doing today. One other kind of idea that they throw at is, what if I want to convert my data? Will it stay normal? So the main idea is what we just talked about, but what if I take each data point and I add to it 6? So each data we add 6. Will it stay normal? Yes, that it will stay normal. That's what we say here. Yes, it does. What if I take each data point and I convert it to from inches to centimeters? I don't really care what the conversion is, but will that new data, will those centimeters now be normal? Well, yeah, they're all staying in that same proportion, so they're staying normal. Of course, your mean, median, mode, and all those are going to change, but it is staying normal. But what if I take each data point and I take the log? Seems crazy, but we actually do this in stats, definitely in a more advanced concept and a little higher level. But if we take the log, our data doesn't necessarily stay normal. So you have a couple questions that just ask, what if I add this? Will it stay normal? What if I times every number by 2? Will it stay normal? Think it through, does it change the distribution, the way it's distributed, right? It's not going to change a bell to a uniform or to a binomial or a different distribution. Okay, so let's look at example one. I already did the histogram for you, so kind of ignore my QQ plot. Just don't look here yet. If you look at that, doesn't that look pretty normal? It does to me. And now some people will be like, no, it looks right skewed. Well, that's when we have to be like, okay, look. And then we have to decide if this has outliers. This one does not have any outliers. And so then we're on to step three, which would then be, does that QQ plot look like it's in a straight line, no patterns at all? It can't twirl, for example. See how this one twirls? Can't have that. This one is should be at about a straight line. Pretty good. So yes, this one shows normal. All right, so this one shows normal. So example one is normal. Example two, you should already look at that histogram and know that is uniform. Okay, so we know this looks uniform, but what does that QQ plot look like? It definitely isn't a line. It's got like a curve to it for sure. So if you curve it all, not normal. Okay. And so it goes through that kind of idea there. What if this is a clearly right skewed? This one's clearly right skewed, not like this one up here, where people think because it has one or two little dots over or squares over there, it looks right skewed. This one is clearly right skewed. And look at, so we know this is skewed to the right. Look at the QQ plot. There's definitely not a line. So this one is definitely skewed to the right, not normal. Skewed to the right is not normal. Okay, it's skewed to the right. That's the distribution. So we can have skewed to the left, skewed to the right, normal, uniform. Those are R and R class, the most common that we talk about. We do talk about binomial distribution, but not in this case because we're just doing, you only have yes or no or like two answers. So you can't make a histogram of words, which is usually yes, no type question. So we're not going to look at that distribution and in this context at all. Okay, just please note, read this through. There are other methods. These are them. There's more advanced methods. We're not going to touch them. The book does cover them, but we're not going to. So let's go ahead and look at an example. So the data is in front of you, but I have a link here to the data just in case you have a printed version, you have the data. But we have the data in a link. So I'm going to click this data and it says sample data for the arrival delay times in minutes of airline flights is given below. Determine whether they appear to be from a population with a normal distribution. Assume that this requirement is loose in the sense that the population distribution need not to be exactly normal, but it must be, the distribution must be a roughly bell-shaped. Okay, so let's click, and I'm going to open that data up in StatCrunch. I might have to sign in. Yep, I have to sign in. Give me just a sec. Where's my sign? All right, so here's StatCrunch. So on our list, our first thing we need to do is our histogram. So graph, histogram of this data, compute. Here's my histogram. Does that look bell-shaped? Nope, I'm done. That's it. There's no question that's not bell-shaped. It's not like it's fairly normal with one extra little box or something like that. It also definitely looks like it has an outlier. So let's look and see if it surely does. So I'm going to graph the box plot because that will show me if it has an outlier by dots. It has two outliers. See them up there? So that is for sure it has outliers. So it has two. So two things, not a histogram, two outliers. So this is definitely not normal. So has two outliers. And histogram is not bell-shaped. All right, that's it. This is probably going to be a fast lecture and a fast homework, but it's still important. Now let's look at my last example. So we've done this data in the last lab. It's like The data is going to be freshman 15. Did you gain that extra weight? So um, we cannot look at all these data sets, but there's 5 data sets here. If we look at that first row, it's the sex, right? Male, female. Can I do a histogram? No, right? Because histograms are frequency of numbers, not numbers. Only thing I can really do is a bar graph or a pie chart of that data. So we don't really care about that data. So we're just gonna do them all at once. We're gonna do a histogram of all of them. So I'm gonna click all of them. On your computer, you can hold down control and you could click all of yours like I can on an iPad. Super easy on an iPad compared to the computer. It's a little bit trickier. So control Mac users, I think it's your you probably know more than me. It's like a little bit labeled different. Okay, so this is weight for September. Oh, I mean, we're gonna need to look at a QQ plot. I don't really know for sure. Looks not quite bell-shaped, but it's not that far off. So we got to look for outliers still. We'll get there. So I think September's weights, April's weights looks right, skewed a little more, but again, still like questionable. Definitely want to keep going. Doesn't have an outlier. Does the QQ plot form a line? Next one, definitely looks like it has an outlier. This is BMI for September, but man, that one looks bell. And April looks bell shaped too. So our next thing is to look for outliers. So I'm going to do the box plot of all 4 so I can see if they have outliers. Compute. And oh, all of them do, and all of them have more than one. Done, not normal. Okay, so I thought about using different data because I wanted like one of them to be normal, but the data that the book has, like almost all of them had outliers. So I was like, crap, let's pretend that the BMI doesn't have outliers. It does, I know. And let's at least show you how to do a QQ plot. So here it is, quartile QQ all the way down here. QQ plot, and this is your plot that you need. Let's do BMI for both April. Let's just do them all. Why not? Compute. Okay, so here is, see, it says weight for September. Definitely not looking normal, even though it had outliers, but so we shouldn't have even done this plot, but I wanted to show you it. Next data set doesn't look normal. The BMI data actually looked fairly normal, but look at it. It's like curving all the way up, not working for us, and neither is April. So we can see they're definitely not forming a good line, and we had too many outliers. So not normal, all 4 sets of data that we could look at. So however we want to put that, we could say BMI, both September and April, right? I think it was April. Have outliers, have 2 outliers. So not normal. And the weight, oh, well, let's just add weight here, then we don't have to write as much. Weight for both September and April. And those were all kind of questionable histograms anyway, but we can look at that and just basically say whether it's normal or not. So pretty easy process. So you look at the histogram, the outliers, and then the QQ plot, and it's a yes or no. Does it look normal? A little bit better than just looking at that histogram and going, I think it's normal. This gives you a little more to go with.